Okay, welcome to our online class. So our topic will be about elimination of arbitrary constants and families of curves. Okay, so let me share to you the presentation that I have here. I have prepared here. So, so let's first learn how to arrive at a differential equation, by eliminating the arbitrary constants. So this is the objective here, how to arrive at a differential equation of the given relation, function, or equation. So, okay, the first criteria for your differential equation, okay, if you're given a relation or a function, and then there's an arbitrary constant there. So the order of that differential equation that we are actually looking forward to be obtaining is it depends on the number of arbitrary constants. Okay, so when the given equation contains two arbitrary constants, it means that its ODE or differential equation is a second order. Or if the given relation or function is or contains three arbitrary constants, it means that the ODE of that equation or relation is third order. Okay, so it just means that for you to be able to obtain or to arrive at its differential equation, you must be able to differentiate the given function as many times depending on the number of arbitrary constants. That's why kung pag sinabing two arbitrary constants, second order siya because you have undergone twice of differentiation. So if there is only one arbitrary constant, then you are expecting a result or a DE that is of first order differential equation. Okay, so the ODE consistent with that relation and should be free from arbitrary constants. That's why we are to eliminate the arbitrary constants. Ones that after differentiating the given function, okay, those are required the number of times to differentiate it, and we're able to see that there are still arbitrary constants in the DE, then we should do something. We should use some techniques or methods how we can be able to eliminate the arbitrary constants. Okay? So that's the idea here, how to arrive at its differential equation. So let's have some examples. I think I have discussed this one, so let me just review or let's just review this example so that you will know the idea of how you can be able to arrive at its differential equation. So the first one here is an equation y equals c sub 1 x squared plus c sub 2 x plus c sub 3. So as you notice, there are three arbitrary constants. So these are c sub 1, c sub 2, and c sub 3. So I am asked to find the ODE, okay, of this equation, of this given. Now, for me to arrive at this DE, I should be able to, I must differentiate this one. So the question is how many times? So the number of times you are to differentiate this equation depends on the number of arbitrary constants. Since there are three arbitrary constants, so I should differentiate this given equation 3 times. Okay? There are instances that, after differentiating, you can be able to eliminate the arbitrary constants. But for cases like you cannot be able to eliminate the arbitrary constants by just differentiating the given function, then you must, do something or you must, work on the equations involved and taking note na kung ano yung order ng DE. For example, if it's third order, so it must contain third derivative in the final answer. Or if it's first order, so your answer, since it's differential equation, it contains derivative. Okay, so now let's work on this one. So first, we will differentiate this for the first time, and that is y prime equals we copy c sub 1 and then differentiate x squared, and that is 2 times x. The second term, so we have c sub 2, differentiate x, so times 1. And last term is c sub 3. It's a pure constant, so derivative of a constant is 0. That's why we have this result. Now, we still have to differentiate again. Okay, first time pa lang to. So the next result is, if you differentiate y prime, it becomes y double prime. And then you copy 2c sub 1, since this is a constant or coefficient in x. And then you differentiate x, and that will give us times 1 here. So you need not write 1 there. And we have c sub 2. So you differentiate a constant, that is 0. Okay, so this is the result of differentiating the equation for the second time. Now, since there are 3 arbitrary constants, I should differentiate this for the third time, and this will become the derivative of y double prime is y triple prime, and the derivative of a constant on the right-hand side of the equation, so you have 0. So after differentiating the given equation 3 times, ayan, so I was able to obtain the differential equation. So wala ka na makitang arbitrary constants here. So it means that this is now my answer, or this is my ODE to this given equation. Okay? This is the case that you need not to do algebra anymore, since you were able to eliminate the arbitrary constants by just differentiating. Okay, but take note that, okay, the differentiation rule here, the number of times you are to differentiate the equation depends on the number of arbitrary constants. So you should not differentiate again, continually differentiate this until you will be able to eliminate the arbitrary constants, because that's not the rule. Okay, so just differentiate the given equation as many times depending on the number of arbitrary constants. Okay, let's have more examples regarding this topic. So we have the next example here, y equals a cosine of x plus b. So this x plus b is the argument. So as you notice, there are 2 arbitrary constants, a and b. It means that I'm going to differentiate this 2 times. Okay? Understood? Na-follow niya? Now you recall how to differentiate a trigo function. So derivative ng cosine is what? Negative sign, right? So since I have 2 parameters here, or 2 arbitrary constants, this will be differentiated twice. So derivative of y is equal to y prime equals, you copy a, derivative of cosine is negative sine of x plus b, and then you differentiate the argument, and that is 1. So times 1 ka lang dyan. This is the result of the first derivative of the given function. Now, we will differentiate again. So y prime becomes y double prime after you differentiate. And then you copy here negative a, differentiate again, sine. So that will become cosine of x plus b. And then you differentiate x plus b will give us times 1. Okay? Now, this is actually, ito na yung final na differentiation na method natin. So after this, you were able to, to see that the equation still contains arbitrary constants. So you must do something with this equation. So again, you stop doing differentiation. So this is now algebra, okay? Or observe the entire equation here. So as you noticed, the given equation, y is equal to a cosine of x plus b. Okay, so sa final na equation natin, you can see that meron tayong negative a cosine of x plus b. So we can equate, therefore, y double prime to negative of y. Okay, so in that way, we were able to eliminate the arbitrary constant. So this is now your final answer. You can rewrite this into y double prime. Transpose this negative y to the left-hand side. So you have y double prime plus y equal to 0. Okay, any question here? Naintindihan? Okay, now let's proceed to the next example. So y is equal to c sub 1 e raised to um, x plus c sub 2 e raised to negative x. Okay, so there are two arbitrary constants. Take note. So we will differentiate this 2 times. So y prime is equal to, just copy exponential function to guys. So you should recall how to differentiate an exponential function. So e raised to u times derivative of u. Ganun lang yun. Okay, let's proceed. Let's continue. So the second term we have c sub 2. Okay, c sub 2 e raised to negative x. Differentiate negative x. We will have negative 1. So you should put negative sign here. Okay, this is the first derivative. Now we proceed to the second derivative. So y double prime plus c copy c sub 1 differentiate e raised to x. Yan, times 1 minus c sub 2 e raised to negative x, differentiate negative x, and that is negative 1. So negative 1 times negative, you have a positive here. Okay, so this is now your supposedly your final answer kung acceptable yung merong arbitrary constant, but hindi ganon. Dapat your DE should be free from arbitrary constant. So our next step is to eliminate these arbitrary constant or this entire term. Okay, now let's proceed. So as you notice, the first equation or the given equation na itong c sub 1 e raised to x plus c sub 2 e raised to x is similar to your final answer, diba, after differentiating this 2 times. So it means that what? We can equate y double prime to the given equation of y. So in that way, yeah, no arbitrary constants are seen in the final answer. So you can rewrite here transposing y to the left-hand side. So y double prime minus y equal to 0 is the final answer. Okay, any questions so far? Let's proceed to the third example. So y is equal to c sub 1 e raised to 2x plus c sub 2 e raised to minus 3x. Okay, so there are two arbitrary constants again. So it means that you are to differentiate the given equation twice or 2 times. So the first derivative of y is, you have, of course, y prime equals, you copy c sub 1, then you just copy e raised to 2x, differentiate 2x, it will give us 2. Yeah, so the next term, you differentiate this. So you first copy the constant c sub 2. Okay, e raised to negative 3x, and you differentiate negative 3x, and that is minus 3. So you put here minus 3. This is now your first equation, the result of differentiating the given problem. Now we differentiate this first equation. So we have y double prime equals the first term. So we copy for c sub 1, e raised to 2x, differentiate 2x, and that is 2. You multiply 2 to the coefficient. So 2 times 2, 4. And then we have the second term, c sub 2, e raised to minus 3x. And differentiate minus 3x, we have minus 3. So minus 3 times minus 3, you have positive 9. So this will be your second equation. Okay, so hanggang dun lang yung pag-differentiate since dalawa lang yung arbitrary constants. Nakuha? So what we'll do here is we will eliminate the arbitrary constants. Ito na yung steps natin. So what I will do here is I will solve for c sub 1 e raised to 2x. So how can I be able to achieve this one? So the idea is eliminate ko muna yung c sub 2 na part. So as you notice, di ba, negative tsaka positive yung sign. So what I will do to eliminate this part, yung c sub 2, is kailangan they have the same coefficients. So what I will do here is I will multiply the entire equation 1 by positive 3 para maging 9. At kapag pinag-add ko sila, when I add them, this part of the equation will be eliminated. Okay? So here, The equation one will be multiplied by 3. And then I will add that to equation 2. Okay, follow? Now, I will multiply now the entire equation 1 by 3. And this will give me um, left-hand side 3y prime equals, okay, the first term will be 3 times 2. So you have 6 c sub 1 e raised to 2x. And the second term here, 3 times negative 3. So you have minus 9 c sub 2 e raised to negative 3x. Okay, so this is now the equation 1 multiplied by 3. I will add now equation 2, and that is y double prime equals 4c sub 1 e raised to 2x plus 9 c sub 2 e raised to minus 3x. Okay, so add lang natin sila, combining like terms. So the left-hand side, so you have 3y prime. It has no other y primes there. So just copy. And then y double prime, wala namang kapareho. So just plus y double prime. On the first terms of each equation, so you have 6 plus 4, 10 c sub 1 e raised to 2x. The next terms of the equation, so you have minus 9 and plus 9, so maka-cancel siya. That's why we have c sub 1. Okay, so we can remove the 10 there by dividing both sides by 10. So c sub 1 e raised to 2x equals, okay, 3. We interchange their positions. Okay, 3y prime plus y double prime all over 10. Okay, we divide both sides by 10. That's why we have now c sub 1 e raised to 2x. Okay, so I just copied the first two equations. So now we'll work on c sub 2. Okay naman, solve naman natin yung c sub 2 e raised to minus 3x. So now it means that I'm going to eliminate c sub 1 here. So I will multiply the entire equation 1 by 2. Okay, and that will make magiging positive pa rin siya. So if I'm going to add, so I should be making this term negative. So multiply ko siya by minus 2. Okay, the entire equation 1 by negative 2. And then I will add positive 2 because the idea here is to eliminate the first terms. Okay, yung c sub 1 na part para masolve ko yung c sub 2 e raised to negative 3x. Let's continue. So multiplying the entire equation 1 by minus 2. So I will have minus 2y prime equals negative 4c sub 1 e raised to 2x. This will become positive 6c sub 2 e raised to negative 3x. I have now this equation, and I will add equation 2 to this resulting equation. So y double prime equals 4c sub 1 e raised to 2x plus 9c sub 2 e raised to minus 3x. Okay, so the idea here is nang pag-multiply ng negative 2 para maging the same yung coefficients nila. So, but of different signs. So in that way, we can be able to eliminate, right, the c sub 1 here. Combining like terms, so we have on the left hand side, you have minus 2 y prime plus y double prime since wala naman silang kaparehong terms. On the first term, so makancel na natin yung 4 c sub 1 e raised to 2x. And then we have 6 plus 9, the same term, diba? The same function. So 15 c sub 2 e raised to minus 3x. Now the idea here is to solve for c sub 2 e raised to, okay, I forgot to write. So e raised to minus 3x, okay? Now let's continue. Okay, so we divide both sides by 15. That's why we have 2y prime minus 2y prime plus 11 plus y double prime all over 15. Okay, so this is now the value of c sub 2 e raised to negative 3x. Now what we will do is we substitute c sub 1 e raised to positive 2, c sub 1 e raised to positive 2x and c sub 2 e raised to negative 3x to our given equation. And that is y equals c sub 1 e raised to 2x plus c sub 2 e raised to negative 3x. Okay, so now you plug in the values. We now have y equals the first term c sub 1. So if you recall, kanina, we have solved already. 3y, 3y prime, okay, plus y double prime all over, okay, 10. And then you add or you plus c sub 2. Ano yung value ni c sub 2 e raised to negative 3x? So you have minus 2y prime plus y double prime all over 15. Okay, so now we simplify. This is now actually your differential equation. So wala nang presence ng arbitrary constants. But what we will do here is we simplify. Okay, this is the challenge here. We will simplify the resulting equation. So after substitution. Okay, so let me just erase the drawing and let's continue erasing the board. Okay, so now we rewrite again the equation. So any questions, guys? While I'm rewriting the equation here. So this equation has or is free from arbitrary constants. So the next steps will be simplifying. Okay. So as you can see, you have over 10 and over 15 for the first two terms. So we will um, multiply both sides by its least common. Okay. The multiple, and that is 30. So multiplying both sides by 30, so we can simplify, diba? So 30y on the left-hand side equals, the first term will be 30 divided by 10, so that is 3 times 3y prime plus y double prime. Okay, so plus, yung second term, 30 divided by 15, so we have 2. So you write here 2 times minus 2y prime plus y double prime. Okay? Now, we distribute the factors here. So 3 times 3, 9, y prime plus 3, y double prime minus, so 2 times negative 2 is minus 4, y prime plus 2, y double prime. So in this part, you combine like terms. So you have y double prime, y double prime, y prime, and y prime. Okay, so just copy 30y 9y prime minus 4y prime. So you have 5y prime and 3y double prime plus 2y double prime is 5y double prime. And now since may common factor sa kanila, divide both sides by 5. You can be able to simplify the equation. Will give us 30 divided by 5. So you have 6y equals, and makancel na yung 5. So y prime plus y double prime. Okay, so this is our final answer. We can rewrite this according to the highest derivative. So y double prime plus y prime minus 6y equals 0. Okay, second order differential equation, linear siya, right? Now, our next example. Okay, before we proceed, any question, guys? None? Okay, were you able to follow?
Yes, sir.
Okay, good. Let's proceed. So our last example here will be x minus c sub 1 and raised to 2 plus the quantity y minus c sub 2 raised to 2 equals 1. So as you notice, there are two arbitrary constants, c sub 1 and c sub 2. It means that for us to be able to arrive at its differential equation, we need to differentiate this given equation 2 times. Okay? Nakuha nyo na yung, yung steps? Count the number of arbitrary constants and then you differentiate. okay, depending on the number of constants or arbitrary constants. Okay, let's proceed, Sir Phil. Okay, we have to differentiate this one 2 times. Okay, chain rule. So we have the exponent 2 times x minus c sub 1 and differentiate now x minus c sub 1, and that is 1. Plus, second term, so you have 2 times y minus c sub 2. Okay, raised to 1, multiplied by the derivative of y minus c sub 2, and that is y prime, equal to derivative of 1, which is 0. Okay, so we can simplify first before proceeding to another differentiation. So common yung 2. So we can divide both sides by 2, giving us x minus c sub 1. Okay, we can group this one. So plus y minus c sub 2 times y prime equals 0 divided by 2, or 0 times 1/2 is 0. So we label this as our equation number 1. Okay, and just a reminder, so you can actually, there are many techniques or ways to simplify this one. So this is just one way how you can be able to um, eliminate. I mean, the differentiation part, so the same lang pala, but pagdating dun sa mismong pag-simplify, so you can do whatever you want for as long as it's the right method, or you have done, or you have followed the right principles or theorems in simplifying the resulting DE. So what we're doing now right here is we differentiate again for the second and final time. So you have 1 being the derivative of x and 0 for c sub 1. Here, we are going to use product rule, yung udv plus vdu. So you copy this y minus c sub 2, you differentiate y prime, and that will become y double prime, plus you copy y prime, differentiate mo yung nasa loob, that is y prime minus 0, or just simply y prime equals 0. Okay, we arrange the resulting equation. So we have 1 plus y minus c sub 2 times y double prime plus y prime times y prime is equal to y prime squared. Or you can remove the parentheses there. So understood na yun, y prime squared. This is our equation number 2. Now the next step will be, okay, how we can be able to eliminate the arbitrary constants, since after differentiating for the second time, you can still see arbitrary constants. So we will use equation 2 to solve for, yan, solve natin y minus c sub 2. Okay, means that we are going to arrange the equation. So solving for y minus c sub 2, and we substitute, we substitute the result to equation 1. Okay, so now we write first, so y minus c sub 2, from equation 2 times y double prime. Transpose natin yung 1 sa right side and y prime squared sa right side. So you have minus 1 minus y prime squared. Now to solve for y minus c sub 2, you should eliminate, or tatanggalin mo yung y double prime dyan. So you divide both sides by y double prime. That's why we have y minus c sub 2 equals, common yung negative, so you factor out negative. So you have minus times the quantity 1 plus y prime squared. Okay, all over y double prime. Okay, now this is now the equivalent, or y minus c sub 2. So the result here is that, or we label this as equation number 3, and we plug in this equation to equation 1. Okay, so we substitute now. So before that, we copy equation 1. So that is x minus c sub 1. So just write x minus c sub 1 plus, ano yung y minus c sub 2? Ito yun. So, negative times the quantity, okay, 1 plus y prime squared all over y double prime. Okay? And then equal to, okay, so you have y prime there, equal to 0. So this is now the result of plugging in the value of y minus c sub 2. So after that, we will solve for x minus c sub 1. So i-transpose natin itong term na to dun sa right-hand side. Okay, so we have x minus c sub 1 equals, transposing this term to the right side will become positive, di ba? Yung negative magiging positive. So 1 plus y prime squared, yan, times y prime over y double prime. So this becomes our equation number, yeah, last equation. So we can plug in, di ba, yung values ng equation 3 and, okay, na-follow ba ninyo? So this will be labeled as equation number 4. So the next step will be you substitute equations 3 and 4. Saan mo siya ilalagay? I-plug in dun sa given equation natin na x minus c sub 1 raised to 2 plus the quantity y minus c sub 2 raised to 2 equal to 1. Okay, so we plug in now the values of equations 3 and 4, itong equation 3 and 4. So first term, you have 1 plus y prime squared times y prime all over y double prime. Take note, naka-square siya. So raised to the power of 2 plus yung second term naman natin. So we have y minus c sub 2. So that is negative times the quantity 1 plus y prime squared. Okay. All over y double prime. Yan, equal to 1. So naka-raise to the power of 2 siya. Ito guys, naka-square dapat ito. So pakilagyan na lang ng square, Sir Phyl. Okay, maybe I've forgotten to write square. Yan, please write. Okay, may chat dito. Sir, ano po yung passcode? Sir Phil lang po. Okay, so now you can see that may, di ba, common yung kanilang denominator, no? You can combine them, or first we rewrite, di ba? Raise the entire term to positive 2. So 1 plus y prime squared raised to 2, y prime squared, ayan, times y prime squared, all over y double prime raised to 2. Plus, so itong negative na to, pag ni-raise mo sa 2, magiging positive na siya. So 1 plus y prime squared raised to 2 over y double prime squared. Okay, equal to 1. Now we can multiply both sides by y double prime squared para maging isang line na lang siya. Okay, so we will have now 1 plus y prime squared raised to 2 times y prime squared plus 1 plus y prime squared raised to positive 2 equals y double prime squared. Ayan na. So what have you noticed? There are actually may common, di ba? Ayan, common yung ito. Common yung 1 plus y prime squared. So what we'll do is we factor out yung 1 plus y prime squared dun sa bawat term. Raised to 2, okay? Remember? So we have y prime squared sa first term ang matitira, and then we have plus 1 dun sa second term. We have equals y double prime raised to 2. So again, take note, what we factored out is 1 plus y prime squared raised to 2. So dapat may raised to 2 pa yan. Okay, so thank you, Sir Phil, for the correction. Okay, so now what have you noticed? Parehong y prime squared plus 1. So actually, pwede mo silang i-combine na. It will have a power of 3 na. So 2 plus 1 raised to 3 na siya. Okay, so that's it. Ayusin lang natin yung ating final answer. Here you can say y double prime raised to the power of 2. Okay, minus 1 plus y prime squared raised to 3 equal to 0. Okay, may tanong ba kayo dito or clarification sa ginawa? Okay, so I think that's all. Okay, sorry for that. Ito, bakit naging squared siya? Because yung common nga dito is 1 plus factoring by grouping, right? Naka-group na siya. So common ito. So we factored out this one. Anong natira sa first term? Y prime squared. So kung ito yung ma-factor out na natin, ang matitira dito, what will remain here is 1. Okay? So take note that itong function na to is similar to this one. So you can combine these actually yung sa law of exponents lang. So the same yung base. So 1 plus y prime squared. Ayan. So how do you do that? How do you multiply? So you just simply add the exponent. So 2 plus 1 is 3. Okay. So any questions? I think may tanong dito. Sir, pa-accept daw po si Salazar. Okay, late na siya. Okay, next time ha, pag late na, bawal nang i-accept. You can still watch naman the recording after class. Okay? Now, if you have no questions, let's proceed to the next part. It will be families of curves. Okay? Hello? Are you still there?
Yes,
May
sir.
tanong?
Yes, sir.
No questions? Okay, so the next topic will be given naman tayo ng families of curves. So the same idea, the objective here is to arrive at the differential equation of the given family of curves. Okay, so you must be able to recall equations of the curves, equation ng line, equation ng circle, ellipse, parabola, hyperbola. So for you to be able to write the given equation, okay, of that family, to represent that family of curve. Okay, so let's start by this first illustration here. So families of curves. So an equation involving a parameter may represent a family of curves with one curve corresponding to each value of the parameter. So just like this example, family of concentric circles. So hindi lang naka-specify na nasa isang center lang. Ito kasi yung center ay nasa origin. So pag sabing concentric, it means that these circles have the same center. Okay? And that center here is the origin. So the equation to represent this family of curves is x squared plus y squared equal to c squared. It means that itong c na to represent the radius, right? So each value of the radius represents one circle. Okay, just like this one. So c sub 1 is the radius of the first circle. So you have one equation here. C sub 2 is the radius of the second circle. So and so on. Okay, so yun yung gagawin ninyo. So first, you write the equation, and then if possible, you sketch so that you will know, okay, what are the parameters involved in the equation. Okay, constant yung center. So the same center lang. So it will not be a changing or a arbitrary constant kapag ganun. Kasi fixed na yung mismong center. Now let's have some examples here. So you find the DE of the given family of curves. So yun lang yung bibigay sa inyo. And then you sketch the representative family of curves. Okay, so we have here an example. So two examples. The first one, family of lines that passes through the origin. And the number 2 is all circles whose centers are at the x-axis. Okay, so let's have the first example. Family of lines that passes through the origin. Okay, so if you have any questions, just raise your hand or message me here so I can address your questions. Okay, so again, recall the equation of a line. So maybe you have remembered this one. So the slope-intercept form, y is equal to mx plus b, where m is equal to the slope and b is the y-intercept. Okay? So, ilan yung parameters dito? So, lines that passes through the origin. So, it means that the intercept here is equal to 0. Okay? If you are to sketch. Okay, so pag in-sketch natin to, so we will draw the Cartesian plane. So lines, all lines that passes the origin. So ito yon. The only parameter that's, the parameter here is the slope. Okay, each value of the slope represents one line. Do you follow? Intercept naman, 0 naman siya kasi 0 kasi nga dumaan naman siya sa origin. Okay? So, ang ibig sabihin lang niyan, di ba, if you substitute, di ba, the value of x na 0 here and the value of y na 0, your intercept is 0. That's why we have only one parameter. Pero kung iba yung intercept niyan, arbitrary intercept, then we have two parameters, the intercept and the slope. Okay, so do you follow? Let's continue. Now we have y is equal to m times x. This is now the equation of the family of lines that passes through the origin. Only one parameter, and that is the slope. So ibig sabihin, para ma-obtain natin yung dE, we need to differentiate this equation only once. Okay? So differentiating y equal to m times x, that is y prime, equals m times derivative ng x is 1. So it means that, ito na. But we were not able to eliminate the arbitrary constant. So hindi ibig sabihin no na m na lang siya, we are to differentiate again. Hindi pwede. You cannot differentiate this anymore because there's only one arbitrary constant. Okay? Because some of you might be differentiating this one. So after differentiating this, we'll eliminate the arbitrary constant. So this is not correct. Okay? Although na-eliminate mo yung arbitrary constant, pero second derivative na yung final answer or second order na. And that is not, you know, the required answer. Kasi isa lang yung arbitrary constant mo, so your final answer should be first order. Nakuha nyo? So what you will do here is you utilize the first equation. So what is the value of m from this equation? M is equal to what? Y over x. So you plug in this value here in your final as your final answer. Okay, so we have y prime equals y over x. Or you can simply say, diba, y prime is what? Dy over dx yan. Okay, dy over dx equals m, which is y over x, and then cross multiply lang. So you have x dy equals y dx. Or simply say, yung final answer natin in terms of differentials na, yan, y dx minus x dy equal to 0. So yan, pwedeng ganyan yung sagot mo or pwedeng y prime. Okay, or from here pa lang. Okay, just like here. Diba you know naman that y prime is equal to what? The slope, right? Yung sa derivative, diba? Yung slope of the line is actually, diba, first derivative. So dito pa lang, nasagot na natin. What's the given problem? Ito, so we can actually plug in na y is equal to, what's the slope? Y prime, right? Times x. So ganun lang. Or you can simply say y, this is x guys, y over x equal to y prime. Yan, the same lang din. Okay? Clear? Nakuha? So the same lang din yung process. dun sa pag-eliminate ng arbitrary constants. Dito naman, so you are to identify how many parameters present in that family of curve. Okay, so that's why you have to sketch the given curve. Okay, so now let's move on to the next example. All circles whose centers um, are at the x-axis. Okay, so recall ninyo yung equation ng circle. Or firstly, you can draw or you can illustrate first. Family of circles. Yung center ay nasa x-axis. So pwedeng malaking circle, small circle, big circle, and medium size. So the criteria is, of course, all those circles, yung center nila ay nasa x-axis. So recall the equation of the circle with center at HK. Okay, ibig sabihin hindi nasa origin yung center. So center is at HK. But looking at this, given centers are at the x-axis, ibig sabihin may constant dyan. Varying lang yung position ni x, ni h, kumbaga. Okay, so here, k is 0 because what's the value of kapag hk? K is 0, di ba? Constant siya na 0. Yung nagmo-move lang dyan is yung x mo sa x-axis, yung h value. So yun yung parameter natin. And of course, the radius is also one of the parameters because there are, di ba, different sizes ng circle. Di ba? One radius of the circle and one value of the h represents one circle. So this is now the given equation. Okay? So as you can see, you have h as one of the parameters kasi nag-iiba yung position ng circle dun sa x-axis. And yung sa y naman, so constant lang din naman na 0 yung k mo. So r also is one parameter. Okay? So it means you have two parameters, h and r. So what does it mean? So for you to be able to determine the DE, you should or you must differentiate this given equation twice. So what I'm doing now is I'm differentiating this equation. So derivative ng first term natin, so chain rule lang, 2 times x minus h raised to 1. Derivative ng x minus h is 1 plus derivative of y squared is 2y, y prime, derivative of x, or r squared is 0. So this is the first derivative of the given equation na may dalawang parameters. So we rewrite first x minus h plus y prime equal to 0. And then this is not the final answer yet. You are to differentiate again for the second time because of the two parameters. So differentiating this will give us 1 minus derivative of h is 0 plus product rule lang y double prime plus y prime squared. Okay? Ito ay product rule, u dv plus v du equal to 0. So as you noticed, after differentiating this equation, we were able to eliminate the arbitrary constant. Pero tama naman yung rule natin because that's, the intended number of differentiation, number of times that we are to differentiate. Okay? So we will just rewrite the equation or arrange this for our final answer. So we have y double prime plus y prime squared plus 1 equal to 0 is our final answer. Okay, so you have additional exercises. This is a self-test or it's a problem set that you can practice on. I'll be posting again more examples, or I hope I can post 2 or 3 examples with this particular topic. Okay. Well, anyway, if you have any questions, you can message me. Okay, so that's it. These are 2 examples for the family of curves. Okay, how we can be able to arrive at a differential equation of this family of curves. Okay, so let me just resolve some issues here. Let me just